Okay, so this is one of those rules that's been in the code since forever, right? And everybody kind of thinks they know what it says, but it never actually said what most people think it said. Do you have to mark the high leg orange? And the answer has always been no. No, you don't. You had to mark it orange or other effective means. Sometimes orange might not be the best answer. So let's talk about what changed here in 110.15. So still in Article 110, which covers general requirements, 110.15, the marking requirements for high leg conductors were clarified and expanded. All right, so on a 4-wire delta connected system where the midpoint of one phase is grounded. Okay, so let's just stop for a second. I always have a little mental chuckle. If you're preparing for a test, or if you're an apprentice, as soon as you start reading anything that starts talking about a 4-wire delta connected, the answer is orange. Okay? Or the answer is B phase. Because they're either going to ask you, what color does that have to be, or which phase do you have to land it on? You land it on the B phase, and it has to be orange. Right, so, on a 4-wire delta connected system where the midpoint of one phase is grounded, so high leg delta, the conductor with the higher voltage to ground must be marked orange in color or by other effective means that makes orange visible at all splices and terminations. What it used to say is that you had to mark it orange or other effective means. Okay, well, is blue effective or red or pink or purple? I don't know. Who determines whether it's effective? I guess ultimately the authority having jurisdiction, right? I'll tell you what, I had an installation when I was inspecting. We had an existing building that had 12208 and it had 277-480. So for the 12208, they used black, red, blue, and white for the neutral. For the 277-480, they used brown, orange, yellow, and gray for the neutral. So the color orange was all over the place in this building. Well, they happened to buy a 3-phase 240-volt piece of equipment. All right, they didn't make it in a 3-phase 208. They only made it in 3-phase 240. So they ended up putting in a transformer and making it a 3-phase high leg delta, right? A 3-phase 240-volt system. So when they put it in, they marked the high leg orange as required, right? But I talked to them and I said, maybe orange isn't the best color, because what we want to tell people, we want to let people know that something is unusual, right? And for years we used orange to kind of set off the alarm bells and tell people, look, orange might mean there's a high leg. Well, if the color orange is already all over the building, maybe that wasn't the best solution. Maybe marking it pink or purple or something else would have been more effective. Now, as it turns out, in that installation, they really didn't need to mark it anything, because if we read the next sentence, identification is only required at terminations where the neutral conductor is present. Why do we have to mark the high leg? Well, because A and C are 120 volts to ground, assuming we're talking about a 122/40 high leg delta. Phase A or phase C to ground are both 120. Phase B to ground is 208. And if we have the neutral there and we think we have 120, if you connect B and neutral, you're going to get 208, and you might have thought you were getting 120, and you could end up wiping out equipment and starting a fire, right? You could end up really creating a lot of problems. But that's only an issue if the neutral is there. If I connect any two hot conductors from a 240 delta, you're going to get 240, right? Whether it's A and B, B and C, or C and A. Or if you connect all three of them, you're going to get 3-phase 240, right? The high leg doesn't matter unless you have the neutral present. So in my instance, they actually, it didn't really matter because they weren't using the neutral at all. All they had was a 3-phase 240-volt piece of equipment. So they came out of the transformer, disconnect, down to this piece of equipment, and that was all they were ever going to use that transformer for, right? So in that instance, they did mark it orange. Did it create a problem? No, because, somebody could have looked at it and not really known, but who cares? It was only going to one specific equipment, and they didn't even have a neutral at that location, so it didn't matter. But, this is kind of one of those funny code sections, and this happens to all of us, myself included. We'll think we know what the code says, and we'll read it the way we want to read it or the way we think it's supposed to be, even though sometimes that's not what it says. You know, I remember making a video years ago where I was teaching a class on section 320.23 talking about wiring in attics, right? The 7-foot protection rule. I made a video years ago and told the story about how I had a first-year apprentice. Guy was as green as the grass. He just raised his hand and he said, "Ryan, that's not what the code says. You're absolutely wrong." And I was absolutely wrong and he was absolutely right, and I had to completely change the way I looked at that section. I made a video explaining it. I didn't know anybody in the industry that was actually reading that rule correctly. And I think this might be one of those rules where people just think, oh, you have to mark it orange. Well, that's not quite what it said. Maybe it always should have said that. Now it does. It does have to be orange or marked some way that makes orange visible at all termination points. It could still be a purple wire with orange phase tape, or it could be a orange wire with purple phase tape. Well, whatever it is, as long as you can see the color orange at the terminations, that's what you have to do. All right, everybody. Next video is on 110.16, arc flash hazard warning, and it is a big change, especially if you're a commercial contractor. You really need to understand what happened in 110.26 because it is a game changer. All right, see you guys on the next video when we talk about it. In the meantime, be safe. Take care.